All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over the PowerPoint presentations for Course Technologies, JavaScript 6th edition. I'm on Chapter 9 of 12, so we are on page 618 of the book. The chapter is entitled Managing State and Information Security. And as you can see, we have just a couple objectives for the chapter. We want to be able to save information, state information with query strings, hidden form fields, and cookies, and describe JavaScript security issues and employ coding practices designed to address them. All right, you may or may not be aware of this, but in many ways, web servers are, work with HTTP, but they're stateless. In other words, if I go out and I'm on my browser and I make a request at Amazon and it goes out to a server someplace, then I make another request from the same browser to Amazon again, as far as the servers are concerned, because HTTP is what's referred to as a stateless protocol, technically the system has no clue that it's me making two different requests. All right. As far as it's concerned, it's just two different machines making the request. All right. So state information, as it says, is information about individual visits to a website. And again, HTTP is stateless. So no persistent data is stored. But you might want to do that. For instance, if you've got a shopping cart where you have to send information from page to page to page, you're going to need to maintain state information. All right. You might customize individual pages on a website. You might want to send information to different pages. As it says, you might want to store information within a multi-part form. But regardless, when you do this, what we're talking about is you want to be able to preserve something. All right. So, saving information with query strings. If I come in here, and I will do this, shouldn't take me very long. I'm going to just dummy up something quickly here. Change this to Chapter 9. All right, and I'm not going to worry about even that array.js file. For now, I'm just going to open up my index file, and I'm going to add a couple things to it. All right, so but this is good because there's almost nothing in it, so that actually works out really well. I can just remove this stuff, and I'm going to put a form in here. And again, it's going to be a very, very simple form. Let's suppose that we're going to ask the person input type equal text. In fact, before we do that, of course, we want to put in our label. For equal, we'll call it first name. ID equal first name. Name equal first name. And of course, we'll just call this first name. All right, let me move this down because otherwise it's just going to be too hard to see what's going on here. All right, and then we will end the label. All right, and then here's our input type equal text. We got for equal first name. We don't need an ID and a name for the label, so that was superfluous. Let's get that out of there. And we'll put that here. And then we'll bring that down here. So now we have our ID and our name. That's good. All right, so that's the first thing we want. Let's hit enter. We'll put a line break after this. And then we'll have last name. And finally, we'll come in here and we'll use email. That'll be it for as far as what we're going to put in the form here. We'll add a submit button in just a minute. We don't need that, that's fine. We'll make this type email. Sorry, you have to pause for a second. All right, so this will be email, and this will be email. We need, let's add a couple more line breaks here. And finally, we'll come down and we'll put in input type equal submit. ID equals submit. Name equal submit. Value equal run program. I know that's stupid, but that's fine. So let's see what we have right now. All right. Again, I'm keeping this as simple as possible. You'll see what I'm doing, hopefully, in a matter of seconds, if I didn't make any mistakes. So let's run this. All right, there's the first name, there's the last name, there's the email. Notice if I put in here Jeff Scott, all right, and jscott@gmail.com. All right, notice what happens when I click Run Program. Watch what happens up here in my address bar. See how it sends that information? It sent it right here. That is known as a query string. By default, it sent this, and it sent it in what's called a get. All right, because that's the default. Now, I could pretty this thing up here, and I probably should, just so it looks a tad more presentable. So normally, again, I'd put this in a separate file, but I'm going to say style, label, display, block, inline, width, 200 pixels, font weight, bold, that should be enough for that. And let's see what that did. Oh, that looks pretty bad now. I don't know what I did. Okay, I screwed up my CSS somehow. I didn't put an ending style tag in. That's what happens when you try to do things too quickly. All right, so it's looking better. That's bolded, but it didn't display that the way I wanted it to. So let's see if we can figure out why that happened. Label, display. Let's just display it inline with a width. 200 pixels should be plenty. Oh, wait a minute, that actually all should be okay. Label, 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 and yep, label. I don't see anything that looks like it should be wrong there. But it's not giving me my 200 pixels of width, which I don't understand. You know what? I'm going to just say the heck with it. I'm going to display this block so each thing will be on its own line. Okay? It's going to look a little goofy, but it'll work just fine. There. Boom, boom, boom. So let's put a little padding, top 25 pixels. That's fine. Okay, so when I come in here, you'll notice what it says right now. It's got the name of my file. But since I didn't put anything, remember in the form tag, I can put in here action equals. And that says where do I want it to go. I don't want it to go anywhere, so I'm just going to put that. But I can say method equals, and I can say either post or I can say get. And I said nothing the first time, so it defaults to the word get. All right? So watch what happens when I run this. In fact, I'm going to make sure that I'm running a brand new occurrence, so I'm closing what was open before. I'm going to rerun it here. So there it is. I come in here and I type in Jeff Scott and jscott@gmail.com. Okay? Now watch, as soon as I click run program, watch what happens here. This right now, notice where it's blinking. That's right now what I have on the screen. Well, now look what was added. Since I used what's called a get, it adds a query string. The query string starts with the question mark, and then it says I've got a field called first name, and its value equals Jeff. The ampersand means I've got another field in here that's called last name, and its value is Scott. Then another ampersand which says I've got email, and it's looks a little funky here. jscott%40gmail.com, because it can't show the @ sign, so it basically shows a representation of the @ sign. But the point is, all that information was actually sent here, okay, and it was sent as part of the query string. Now notice if I change this to post. All right, so I changed this right here, where it previously said get, I changed it to post. All right, I'm going to again make sure I'm running from a clean slate. So run, and just as we did before, I'm going to put in here Jeff and Scott and jscott@gmail.com. Then I'm going to run the program. What don't you see here? That information was not sent as part of the query string. That is one of the differences between using post and using get. All right. Whoops, I don't need that. So, the query string, as mentioned right there, is a set of name-value pairs. You saw, for example, it said first name, that's the key, and then, or the name, and then Jeff Scott, that's the value, or Jeff, that was the value for first name. Again, it was appended onto the URL, and it was put there, and it had a question mark after it. So that's one way of passing information from one page to another. Now, you can actually do this yourself too if you want to or need to. You can add a question mark after a URL and follow it with something similar to what we just did. So if we look at this example right here, all right, here is what we're going to. We're going to www.example.com. All right, add item.html. So we're going to add an item. So notice that question mark. We are adding an ISBN that's got this and a quantity that equals that. So we'd be, basically saying that we want to add an item, and actually two of them, but we showed the ISBN in there and the number that we wanted to order. As it says, pass query string is assigned to the target web page location object's search property. All right, so the query string, as you see right in the middle of the slide right there, that's what it is. It's available as the value of the search property in the location object. And you may remember that location object is basically kind of a history. All right, then they tell you how you can parse this out to get what you need, and then convert the individual pieces of information. All right. Now, saving state information with form fields. There are different ways that you can do this. All right. One of the ways that you can do this, as it shows right there, is you can use what's called a hidden form field. A hidden form field is not displayed by the browser. So it allows users to hide information from users. That said, if you do go to the web page and right mouse click on the web page and you choose View Page Source, you can still see the hidden fields. But typically, there's two reasons why you might use hidden form fields. One is you might use it as some kind of a gotcha type of field, where if you want to show that something has or has not happened, you could check that field. All right. And the other reason that you use it typically is it's for things that technically you don't need to show. For instance, if I have some kind of a site that I'm doing that's an e-commerce site, I might on a person's page when they're checking out, I may show them their amount and their tax and their total. But I really don't have to show them on the page what the actual tax rate was typically. All right? So I could put that into a hidden field. All right? You create it with the input element, but where we have been saying things like type equal text, we could put in there type equal hidden. All right? So notice if I come back to the form that we were just at, all right, I'm going to come back to the same form, and I'm going to add one more field in here. We'll put it, yeah, we can put it after this. That's fine. In fact, we'll do it like this. All right, I'm going to just add that here. All right, and this is going to be a label for, we'll call it hidden field, which is kind of a, in fact, we don't need a label because it's hidden, so we'll just leave that off. All right, so type equals hidden, ID equals hidden, name equals hidden, and we'll put in there, just so you see it, value equals Jeffrey Paul Scott, which is my whole name. All right, but it's a hidden field. So I'm again going to close what I had open, and I'm again going to run it right from here. And what you notice is you don't see it. All right. Now let's see if we put in here Jeff. In fact, let's put a different name so there's no confusion. Donald Trump. Email thedonald@gmail.com. All right. So now I'm going to click Run Program. Now, since it was, I guess we had a post, so it's not shown in there. But let's go and put those same values in, but change this back from post to get. And let's see if it sends our hidden field here with a value of Jeffrey Paul Scott in there. All right. Again, I'm going to close the one I had open, change that from post to get. I did, and run it. And again, we put Donald, Donald, oh, come on, D-O-N-A-L-D, Trump, thedonald@gmail, that should be gmail.com. So let's run it. Oh, it says I put the dot in the wrong place. And since I made it an email field, it actually did some validation for me. That's a good thing. So run. All right. So notice it sent the first name, it sent the last name, it sent the email, and it even sent the hidden field because it had a value. Otherwise, it would have said something like hidden equals and it wouldn't have shown anything. But notice with my page up, if I do right mouse click and I choose View Page Source, all right, then I can still see the hidden field. All right, let's continue on then. All right, so saving state information with hidden form fields. User computes something, submits it, completes it, boom. All right. This is shown in the book on page 629. So the form in this example includes hidden form fields that correspond to the fields from the first page. However, they're empty and users can't interact with them. All right, so they have you actually do some work on this on pages 629, 630, 631, 632, 633, and 634. All right. Well, what if you don't want to store information with hidden fields? Well, what we'll talk about for the rest of the chapter, or most of the rest of the chapter, are using cookies. Now, the big thing with cookies is this right here. Cookies are stored on the user's computer. They're written by the server, but they're written to the user's computer. All right? If you've ever worked with sessions, and if you haven't, you will. But if you've ever worked with sessions, sessions write their information to the server, where cookies write to the client. So these query strings that we talked about before, they don't permanently maintain that information. It's there, but as soon as you change pages or go back or whatever, that information is lost. So once a web page that reads the query string closes, the query string is lost. Hidden form fields do maintain information, but again, the data are lost once the page that reads the hidden field closes. So the most widespread way of doing this today is to use cookies. Again, as mentioned there, cookies are small pieces of information, typically a maximum of 4K or 4,000 bytes in length. They're stored in text files, so a lot of people will say cookies are evil. They're not executable files, they're just a text file. And normally, the system only lets you save X number of cookies on a machine. Maybe it's 20, maybe it's 40. Okay? Now, one of the things that's happened with HTML5 is there's something that's called web storage that sets out standards for storing more information than cookies allow, using a syntax that's a little bit more intuitive than cookie syntax. All right? When you create cookies, there's two ways to create a cookie. You can create a persistent cookie, and a persistent cookie, when you create it, you give it a time that it's supposed to expire. I literally could create a cookie right now and tell it to expire in 1,000 years. All right, so it'll expire well after I do. All right, but I can also have a non-persistent cookie, and those typically expire either right after you let the either right after your session ends, or sometimes, within 20 minutes to 30 minutes of when the session ends. And the book calls those temporary cookies. All right. So there's your information about cookies. It's pretty much what we've just said. Small pieces of information stored in text files. Most cookies are set up, unless, again, you give them an expiry date. They remain only for the current browser session and maybe 20 minutes afterwards. Persistent cookies, you give an expiry date to, and if it's in the future, all right, then of course they'll stick around for as long as you tell them to. So here are some of the limitations of cookies. Typically 20 cookies, sometimes I've heard up to 40. Total cookies per browser, and the largest cookie size is 4K. Again, all that stuff that they show right there is not enforced by all browsers. So, to create a cookie, and they show this on the bottom of page 635 and on your screen, you say document.cookie equals, all right, and at a minimum, you have to give it the cookie a name and a value. But you can also give it a date that it expires, a path where the cookie is applicable, a domain where it's applicable, and secure. And if you set secure, then what you're saying is you want the cookie to be HTTPS. So here are the cookie attributes as shown on your screen right here, and also on page 636 in the book. So let's talk about each one of these. The name attribute, again, is really all that's required, but it doesn't make any sense to have a name if you're not going to have some kind of a value also. All right? So as it says, it specifies the cookie's name-value pair. Cookies are created, again, a temporary cookie is created only with a name attribute, with the name and the value in it. All right? And as it says, something gets added by the system for you when you do that. Here are some examples. So notice, that's literally what the cookie would say, username equals. All right? So if you put these three things in there to build a list of cookies and then you dump the cookie property, that's what it would show you. Cookies cannot include semicolons or special characters. And as it says, you can use special characters in cookies if you use encoding. And if you go, I don't know what encoding means. Yes, you do. Because remember, when we just looked at this, all right, and we ran this, you saw how when we did this, it said J. Scott, and it said that %40. That's a method of encoding. And what it's doing is it's setting up something in a way that the system will understand it. It's not done for your benefit. It's done for the benefit of the system so that the system can understand what it is you're trying to do. As it says, it involves converting special characters in a text string like the @ sign to their hexadecimal ASCII value, preceded by a %sign. So 40 would be the ASCII value. All right. Notice too, under this creating and modifying cookies, that they talk about in here encode URI component, used for encoding the individual parts of a URI. We're used to using the word URL. URL stands for Uniform Resource Locator. Something you put into an address bar, etc., and you go to a website. Well, a URL is a type of URI, which is a Uniform Resource Indicator. All right? One of the differences between a URL and a URI is technically a URI, if you put an address in for a URI, it doesn't have to exist. All right? So as it says, the encode URI component is used for encoding the individual parts of a URI. It converts the special characters for you, and there's the syntax. When you encode something, typically you have to decode it, which is turning it around, and they show that right here. Testing applications that use cookies. All right. So some browsers don't support setting cookies when HTTP is not used. There are all sorts of things. Cookies are not inherently bad. All right. But, if you do set a cookie and you put private information in there, it's not inconceivable that someone may be able to go and get the value of that cookie. All right. So this testing thing is on 638 in the book. Cookies are part of the HTTP spec, which is the protocol used, as you know, to request files from a web server. But when you're developing and testing web documents on your local machine, browsers typically open them without using HTTP. All right. There are a few methods you can use to work around this issue when reading and writing code. You can research which browsers allow cookies to be set on local files and just use those browsers. Or, as it says right here, a more robust option is to run a web server on your local computer and open the files that way. Okay? You can use things like XAMPP, XAMPP, and that actually allows you to use your computer as both a browser and a server. It emulates a server on your own machine. The expires attribute, as it says, you put a date in there, which should not be encoded. And the date you put in, if it's a future date, all right, if it's a date in the future, the cookie will expire on that date. If you have an existing cookie and you basically tell it to create that cookie and you give it a date in the past, that's a way of getting rid of cookies. So again, there are exercises throughout the chapter, including a very advanced one here, or a fairly long one, I should say, on 639, 640, 641, and 642. So for a cookie to persist beyond the current browser session, you need to use the expires attribute of the cookie property. This attribute determines how long a cookie can remain on a client's system before it's deleted. If you create a cookie without an expire attribute, all right, then as soon as the session ends, typically the cookie will go away. And when you do this, I don't know if it shows it in here or not, you set it up typically in a, typically like a month, day, hour, minute type of thing. I don't know if there's an example in the book or not. I'm looking for one, all right, but I don't see it. Again, this entire chapter has just got a running example of all this. Okay, the path attribute is shown right here. That determines the availability of a cookie to other web pages on a server. The path attribute gets assigned to the cookie property along with the associated name value pair using the syntax path equal, and then you give it the path. By default, a cookie is available to all web pages in the same directory. But if you specify a path, the cookie will be available to all web pages specified in the path, as well as pages in the subdirectory. You have to watch it when you do that because, for instance, I can't sit there and put the path at where Google is, for example. I can't do something like that. Cookies from other programs stored in the same directory can cause JavaScript to run erratically. So in other words, read the chapter before you start doing anything with this. Like the path attribute, all right, the domain attribute is used for sharing cookies across multiple servers that are in the same domain. The domain attribute is assigned to the cookie property along with the associated name value pair with the syntax domain equals. All right. So again, you have to keep it in your own domain that you have access to. You can't share cookies outside of that domain. The secure attribute, as mentioned before, if you set the secure attribute to true, what you're saying is you want to use a secure socket layer, SSL, now typically known as a transport layer security, I think it is, TLS. So you want to have an HTTPS rather than an HTTP. All right, so the main protocol used to encrypt data is SSL, or secure socket layer. It's currently in the midst of being replaced by transport layer security, TLS, and eventually that will replace SSL. Both of those are set up so that you don't have problems with attacks from people going in and trying to attack and grab stuff from your system. All right. All right. Parsing a cookie. As it says, when you create a cookie, you want to decode it using the decode URI component function. You use the string object methods to pull apart the individual pieces of the cookie. It's very similar, as mentioned there, to parsing a query string. Okay. So there are examples throughout the chapter that go through this stuff, what to do and how to do it. So in this example, as it says, create 3 encoded cookies right there. So there's one, there's the next one, there's the next one. Read them from the cookie property and decode them. Determine which cookie holds the needed value. Use a for loop and an if statement. All right? What you're going to have to do in here. Deleting cookies with JavaScript. As it says, you must set the cookie expiration date to a time in the past. So for instance, there's an example right there. You've already created that cookie and you say expires date dot set date, and we've set it to a date in the past. So when a user closes a browser or window, any temporary cookies are automatically deleted. However, persistent cookies must be deleted by the user. You can use JavaScript to delete persistent cookies. All right, sometimes you need to manually delete cookies in your own browser. So to delete them, again, you can delete cookies in your code, but the way that you do it, as mentioned here, is not exactly intuitive. You must set its expiration date to a date in the past. As mentioned, persistent cookies can interfere with testing. Plus, if other people can grab your cookies, I know that sounds a little weird, but that's actually referred to as cookie hijacking. And if they can do that, they might be able to get on the system and, for lack of better words, be you. You don't want that to happen. All right. The next section of the chapter starts on page 655, and it talks about storing state information using the web storage API. And again, it's important that you realize that this is an HTML5. All right, this is an HTML5 concoction, for lack of better words. So if I want to know about web storage, as we've done several times before, I'm going to come out here and I'm going to go out to caniuse.com. And I'm going to search for web storage. There it is. And it says, well, as long as I'm using a fairly new browser, even IE 8 and above, and a fairly new version of Firefox, Chrome, Safari, Opera, iOS Safari, and the Android browser, and Chrome for Android, I'll be fine. It's only Opera Mini that has a problem with it right now. So it's basically supported on any fairly new browser. So one of the reasons this was done is people are using cookies for ways that weren't exactly designed for. Really, I believe that when cookies were invented, web cookies like this, they were not designed for persistence. It's something that just was added later. All right? So cookies are still the standard, but web storage offers additional features and functionality. As it says, it's targeted at specific browsers, the newer ones. There's 2 types of web storage. There's local storage, and local storage are like persistent cookies. They remain on the system until you decide to delete them. Then there's session storage, which is like a temporary cookie. And it says removed automatically when the user closes the browser tab or window. I don't believe that's automatically. It is, but I don't believe it happens right away. I think, again, there's about a 20 to 30 minute interval, and then it removes them. Storing and reading web storage is easier on cookies. Storing and reading with web storage is easier than cookies because in many ways it's more intuitive. All right, you say local storage dot or session storage dot. All right, there's no expiry, etc., the stuff that's in there. Again, the local storage is saying that you want it to persist, and the session storage is saying that you want it to end as soon as the session ends. All right. On table 9.3, which is in your book on page 656 and on the screen right now, it talks about the fact that the web storage specification includes methods for creating, reading, and deleting stored data. So clear removes all data, clear all by itself. Get item retrieves the value of the item with the name that's in the parens. Remove item removes the item with the name that's in the parens. And set item stores an item with the name and the value as shown in the parens. Remember that when you use these, it's up to you to preface this with either local storage or session storage. All right, and again, there are some examples and a little bit more stuff on that on page 656. All right, the last part of the chapter, which starts on page 657, talks about understanding security issues. And a big thing about understanding security issues is the fact that what you must do is you must assume that everybody is out to get you. And that might, what are you talking about, Jeff? No, what I mean is you must write your code as though people are trying to break into the system. You must be vigilant and you must consider security from the beginning. There's all sorts of security threats and some of them are mentioned there. Now, the server is going to provide some security for you, but the point is, the server security is meant to protect the server. It's not meant to protect the browser, all right, or the client. And since JavaScript programs are downloaded and executed locally on the client, if there's some junk, so to speak, in that JavaScript program, all right, some malware, some bad things, it's possible somebody could do something they aren't supposed to do. So you always want to practice secure coding, also known as defensive coding. As it says, you want to write code to minimize any intentional or accidental security issues. Assume all code is insecure. And there's no magical formula, as it says right there, for writing secure code. Some of the areas of concern: protection of a web page in a JavaScript program against malicious tampering. And I want to show you very simply what I mean. Now, this may not mean a whole lot to you, but what I'm going to do is I'm going to run this program that we had before, that same one. So I'm going to close it. I'm going to run it from a brand new window here. All right. And what I'm going to do is I'm going to put in for the first name, I'm going to put in a script tag. And I'm going to say, alert, please don't print. And I'm going to end the script tag. All right. And then I'll put Scott in here. Well, I spelled my name wrong, but Scott, boy, and the Donald that we put. Okay. Now watch when I click run. All right. That was good because what didn't happen, what did not happen, is it didn't show this. It didn't show the alert. So there is some protection that's been provided. If it would have actually shown the alert, that would mean that I can put JavaScript inside of a web form. Allowing JavaScript in a web form and then actually running it is about as dangerous on the client side as it gets. Because I could put things in there that could conceivably do bad things. All right? Okay. You want to always make sure that if you're passing information and it's of any kind of secure, passwords or credit card information, etc., you want to always protect that. All right? You want ideally you want to send that through a post. If you send it through a get, which means that it's actually shown up in your query string, then you want to investigate and see if there's any kind of encryption function that you can use so you can encrypt that data before it goes through the line, all right, and make it unreadable for other people. But there's all sorts of things that people can do. As it says, there are code injection attacks. Programmer user enters JavaScript code. Well, isn't that what I just showed you? All right. The good news is the people who set up JavaScript, as you can see in this last bullet, set it up so there's certain things that you can't do. You can't create a network connection because you're not working on the network. You're running on a local machine. You also cannot run system commands or execute programs on the client. That's good. All right. Going along with that, the same origin policy that starts on page 659 in your book. Another JavaScript security feature restricts how JavaScript code in one window, tab, or frame accesses a web page in another window, tab, or frame. Under this same origin policy, windows, tabs, and frames can view and modify the elements and properties of documents displayed in other windows, tabs, and frames only if they share the same protocol, such as HTTP, and only if they exist on the same web server. Idea, as it says, the policy should prevent malicious scripts from modifying the content of other windows and frames. All right. Just about finished. I have to pause this for just a second here. All right, sorry about that. So, we've just about reached the end of the chapter here. Okay, they talk about using third-party scripts. Oops, I don't want to click insert. I want to click slideshow from current slide. Sometimes you don't want to run scripts. You want to run scripts from other domains known as third-party scripts. An example of that we'll see when we get to the last chapter is using a content delivery network. We'll talk about that when we get to jQuery. To enable third-party scripts, you include the script element with the source pointing to the third-party content. That's an exception to this same origin policy that we just mentioned. So, not a lot of code in this chapter, but we talked about state information and about the fact that HTTP was originally designed to be stateless, but technically it can't be for everything you want it to do. So to maintain state, we found out we can use query strings where we pass the information along with the URL up on our address bar, but again, it's a temporary thing. Hidden form fields, which don't show directly on the form, but do show if you right mouse click and view your page source. And again, that's temporary. We talked about cookies, which can be either persistent because you set an expiry date for them, all right, and you can tell them to last as long as you want or need them to expire, or you can have temporary cookies, which expire as soon as you finish your web session. The newest thing, the HTML5 thing, is web storage. Whereas cookies only let you save about 4K of information, I believe web storage lets you store about 5 meg, which is 5 million bytes of information. Web storage is more intuitive to use, and it provides session storage, which are like temporary cookies, and the regular local storage, which are like persistent cookies. All right. We've talked all about cookies and a little bit about web storage. And the chapter ended by talking about secure coding or defensive coding, as it says, as a way to minimize intentional or accidental security issues. So that's it for this chapter. When I come back, I will be going over Chapter 10. And Chapter 10, is on programming for touchscreens and mobile devices. So I'll be back with that shortly.